students, right now we are going to understand about motion in a straight line. Okay, so to do that, first of all we need to understand about two important concepts, which is distance as well as displacement. All right, we'll understand that and then we'll see what exactly is the difference between the two, and then we'll move on to some examples. Okay, so first of all, let's see what exactly is distance. And here let's say that this is point A, all right, and this one is point B. Okay, so let's say you want to move from point A to point B and you have taken this specific path, right? This is highlighted right here. And if you have taken this specific path, and let's say you have an inch tape as well, and you're using that to measure the total amount of distance that you have taken to cover this path. So that exactly is known as the distance of any object, which is the total path covered by an object. This means that let's say you change your path. For example, let's say you take the path somewhat like this. And in this case, that is, this blue line is basically the marking of your path taken. You have taken this complicated path, but now your distance is going to be different because your path is different. So this means if you measure each and every point and you measure the total amount of distance traveled from point A to point B, this is obviously different than this red line, right? So in simple words, distance is total path covered by an object. But displacement is something different than that. Okay, displacement is simply the shortest path covered by an object. All right, now you need to understand that this is very obvious as well as a mathematical concept as well, that if this is point A and this is point B, between point A and B, the shortest amount of distance possible is nothing but a straight line. All right, a straight line is the shortest path or shortest distance between any 2 points. This means in this case, if you want to go from point A to point B using the shortest path possible, you need to move in the direction of B along the straight line. Okay, this means you have to take the direction into account because from A to B, you're moving from A to B. All right, so this means displacement comes with a sense of direction as well. Keep that in mind. All right, that means if you're moving from point A to point B, you need to move in the direction of the B in this straight line direction, in this straight line. Okay, so the distance covered by the straight line will be your displacement. Okay, the shortest path possible. Remember that if you're going from point A to point B, your displacement will be along this line, all right, in the direction of the B. And if this totally changes, let's say you're moving from B to A, the magnitude or the amount of displacement will still be the same, but remember your direction is going to be totally opposite. All right, so although the magnitude of displacement is same, but the direction is different. It's totally opposite to the original direction of displacement. Okay, so these are two important concepts, distance as well as displacement. Distance is the total path and displacement is the shortest path, which is the straight line between any 2 points A and B. Okay, now let's put this thing into practice. All right, let's take some examples. So in this case, let us take this first example. In this case right here, I have a train which is moving from station A to station B. All right, so the path of the train is in this direction and then it goes in this direction, then like this, then like this. All right, here the figures are given to you, the distances are given to you, and the simple question is you need to calculate first of all the distance as well as you also need to calculate the displacement in both the cases. All right, so before I give you the answer, pause the video, write both of these quantities down in your notebook and later on you can match it with me. All right, so this means you might have done right in your notebook, be honest. Okay, and here what we're going to do is first of all let us calculate the distance. Okay, now remember the distance was total path taken. Here the path taken is along these red arrows. Okay, so this means that if I want to calculate the total distance, I need to add each and every amount of distance traveled by the train. This means all I need to do is add this 50 kilometers, right? It has moved along this line, which is 50 kilometers. So 50. But the train moved again 100 kilometers of distance along this line. So plus 100. Train also moved 200 kilometers of distance along this line, right? Plus 200. Train moved 400 kilometers of distance along this line. So plus 400. Okay. Add this thing up and you will get the total distance. Here you can see 400 plus 200, 600, 700, 750. So 750, what is the units? Units is kilometers. Now children, keep in mind that in this specific chapter we are dealing with different physical quantities, and each physical quantity has some units, and it is very important that you keep in mind that each time you mention any physical quantity, you have to also mention the units of that quantity. If you do not do that, actually it can be a huge blunder. Because let's say this is 750 and I simply write this 750. But this can be anything. This can be 750 meters, it can be 750 centimeters or maybe kilometers, whatever. This means I have to specify the unit that I'm using. So 750 kilometers is amount of distance. Okay. What will be the displacement here? That's very easy. Look at this. From point A to point B, the straight line distance which is given, that is simply 400 kilometers. So that means the displacement is going to be 400 kilometers. Alright. So very simple example. Now let us try to do the other one. Here I have this case, and in this case once again let's take into the account of the motion of an object going from point A, okay, to point C, and then from C to B. Alright. So this is the motion. Remember that the path taken is along A, C and then B. You have to calculate once again the same things, which is distance and displacement. Alright, and do the same exercise. Pause the video, write the answers in your notebook and then match it with me. Alright, so I hope that you have written the answers in your notebook, right? Here I can see that the object is moving from A to C and then C to B. Therefore, all I need to do is calculate the total path. This is going to be 3 plus 4, right? 3 plus 4 is 7. What is going to be the units? Keep in mind, you have to always take into account the units and you have to write that here. Okay, so 3 meter plus 4 meter, that is 7, 4, 5, 6, 7, yes, 7 meter. Alright. Displacement. Now remember, the displacement is nothing but the straight path along A and B, and that straight path is nothing but this line. And here I can see that according to the geometry of this specific path, this straight line is nothing but the hypotenuse of this right angle triangle, right? This is a right angle triangle. So I want to calculate this distance, but this distance is not given to me. Instead, this 3 meter and 4 meter is given to me. What will I do? Yes, Pythagoras theorem. Alright, so apply the Pythagoras theorem and you can find out this specific distance. What do we know about Pythagoras theorem? AB squared is equal to AC squared plus CB squared. Alright. If I do this, I can simply get the final answer. That will be, here let's see, AB squared is going to be equal to AC squared, which is 3, right? 3 squared is 9 plus 4, right? 4 squared is 16. Okay. So here AB is going to be equal to under root of 9 plus 16. What is 9 plus 16? 9 plus 16 is 25, which is now 5, right? 5 5 is 25. So the under root of 25 is going to be 5. Here the units that I am using is 4 meters, right? Remember, meter. Therefore, this is going to be 5 meter. So here I can write that the displacement is 5 meter, and remember that the distance is 7 meter. Now children, keep in mind that in both the examples, did you notice something? Did you notice that in this case the distance is greater than the displacement, right? Distance is 7 meter, displacement is 5 meter. On the other hand, look at this. Here the distance was 750 kilometer, but the displacement is nothing but 400 kilometer. So displacement is again less than the the displacement is less than the distance, right? This means I can actually now formulate one very important relationship between distance as well as displacement. Okay. First of all, keep in mind distance is total path, displacement is the shortest path. On the other hand, distance only needs a number. Alright, 750 kilometer, I can know that that is the distance of the total path taken. But in displacement, direction must be specified. Okay, direction is important and it comes with the displacement. Another important thing is here, looking at the numbers and examples, we can see that from point A to point B, alright, if the displacement is this shortest path, which is this, then if the object has taken any other curved path, in that case distance is going to be always larger than the displacement. Okay, remember, if the object has taken a curved path, this means I can simply write that the distance is always greater than displacement. Okay, but tell me children, that if an object is moving from point A to point B and the path taken by the object is nothing but a straight line. So the path taken is a straight line, that means that will be the distance, but displacement is also the shortest path, so that means distance as well as displacement are going to be equal to each other. Yes or no? This means that in this case the distance greater than displacement is not 100% true relationship, but I can write distance is greater than or equal to displacement. Okay, so this means in most of the situations the distance is greater than displacement, but there are situations in which the distance and displacement are equal to each other. Okay, so here I can simply say that the distance is greater than or equal to displacement, but remember, whenever distance and displacement are equal to each other, that is the situation in which the object is moving nothing but in a straight line. So in a straight line, the distance and displacement are going to be equal to each other. Apart from that, in any other case, the distance and displacement are going to be different, and specifically the distance is going to be larger than the displacement.